Okay, are we up and running? Are we streaming? I think we are connected. Okay, hello guys, this is going to be a very quick stream just to give an overview of the JL Audio XD1000/1. So this is a very nice amplifier by JL Audio. It's a slightly cheaper, well I say slightly cheaper, it's a slightly simplified design when comparing it to their older Slash series. So this, the 500/1 and the 1000/1, the older ones that are a lot bigger, they are a much more sophisticated circuit. This is a simpler circuit, but it's still a very good design. Now this amplifier came in for repair. Now these JL Audio amplifiers, if I choose the right camera here, now these claim to do, I think they claim to do the same power between 1 and 4 ohms. The driver here and the outputs are quite small. Okay, this is the output section. Okay, we've got 4 FETs and 2 drivers, and this thing will do 1000 watts. So, you know, you're running on pretty small components here for quite lots of power. Now, when run at 1 ohm, it seems that the drivers get pushed a little hard. They get pushed a little hard, and the thing is not particularly reliable at 1 ohm for long periods of time, it seems. I can't see anything else that will cause these things to die. They do die relatively, well, when they come in for repair, there's not anything obvious that's killed them. Usually when you get an amplifier in for repair, you can see that there's like snapped inductors or transformers that have come away or rubbed or something, or, there's usually some obvious reason that this thing went down. With the JL Audio amplifiers, these ones, there doesn't usually seem to be a reason that you can see physically for the point, the purpose that it went down. Having looked at the circuit and the voltages and the heat and everything on there, when you run this thing at 1 ohm, the drivers do get quite warm, and the outputs are pushed quite hard because you've only got 4 outputs here, so you're actually spreading your 1 ohm load over, the current that needs to pass through each of these is quite high. So if you've got one of these, I'd recommend running it at a slightly higher impedance than 1 ohm for daily use. Now, what did we do wrong? So we were repairing this on a live stream, I think last week, and for some reason we could not get the drive on the gates of the output MOSFETs. We just couldn't get the drive to be clean, and we couldn't get it to appear there. So, like, what the hell was going on? So if you ever get one of these amplifiers in for repair, you'll notice that the FETs that it uses are IRFB4410Z, which are very important that you choose the right FETs, and the drivers that it uses, these are very small, so you'll have to like wipe your finger with a bit of thermal paste to kind of to see what the code is on here. And the code of the original drivers that this was using was 2101S. Okay, so 2101S. Now all the rest of JL Audio's amplifiers use international rectifier driver ICs, IR, so it's always IR something, IR2010, IR, etc, etc, IRS 2184 etc. It's all IR, international rectifier. So my assumption was that this one was using international rectifier chip as well, and it was an IR2101S. So that's what we ordered, and on the live stream, when we went to put those chips in, all we needed to do was replace the IC chips. We also needed to replace some of the resistors around this area that died. So we did all of that, and we fixed the power supply section over this side of the board. The power supply section repair went absolutely fine, but the output section, when I took the driver chips off of the board and measured the drive waves, it looked great. So with the driver chips off the board, when I probed the pins where the logic drive was coming into the chip, it looked great. And then as soon as I soldered the driver ICs in place, all of a sudden the logic drive looked very bad, and I was like, what the fuck? What's going on? We couldn't work it out on live stream, and it seemed that the pin configuration for these chips was completely wrong for how they were being used on the board, and we could not get our head around it. So I spoke to a guy who is very, very experienced with JL Audio over here in the UK. He's the official JL Audio repair center for JL Audio, and he said to me, he said, okay, that is a common mistake for you to make, because the driver ICs that this uses are actually HIP 2101, not IR 2101. But the only way to know that is on the chip, there's a teeny tiny little H for the HIP type, which I couldn't see because it's so small, and I would need probably an expensive microscope setup to be able to see that. My magnifying glass didn't do a job at all to see that. So you know, he said that's a fair assumption to make because all the other JL audio amplifiers use the IR chips, but this one actually uses HIP2101. So I ordered some HIP2101, I checked the spec sheet and the data sheet, and the pin configuration was different and it matched up to what we expected to see on the board. So I fitted those and fitted 4 new output FETs, and lo and behold, when I turn her on, we have nice looking drive waves. So this thing is now repaired. Nice looking drive waves on each of the high side and low side here. So that's all it was. That is literally all it was. It was just that we had fitted the incorrect style of driver IC, which was, it was the same number. It was the same number, still a 2101, but it was IR2101 and not HIP2101. So all of that faffing around, the live stream was like a good couple of hours long, and it was literally just that. If you do have one of these JL audio amplifiers in for repair, perhaps I'll just go over where you should have the drive waves and good stuff sing. So on the driver IC chip here, okay, obviously I've got everything fitted, and so things will run differently without everything fitted. But with everything fitted, let's go through what you should have on each pin. I'm going to be very careful because this is currently now in a repaired state. I don't want to slip my probe so that I short anything out. So on the IC chips, on pin number 1, you should have, on pin number 1, you should have about 8 volts. Okay, you should have, about 10 volts on pin number 1. We've only got 10 volts going in on the power supply here, so I can perhaps crank that up a little bit and see if the voltage goes up. Yes, it does. So pin 1 is actually the VCC. So pin 1 is the power for the driver IC. It's what the driver IC uses for power. Now pin 2, I'm going to be very careful here because I don't want to slip my probe and kill this thing again. Okay, so pin number 2 should be a drive wave that looks like that. So it rides slightly off of ground, and it's about 50 volts worth of drive wave, 50 volts RMS. The third pin should also be a drive wave, but it rides on ground, and it should be about 48 volts. And these voltages will change depending on your input voltage. I'm running 10.6 volts into this, so it'll be higher if you're running 12 volts. Pin 4 should also be, I've got a 42 volt RMS drive wave that runs along ground. Pin 5 should be a very, very small drive wave. So this is one of the logic inputs. So this should be about 3.4 volts RMS drive wave, and that's coming from the drivers in the middle of the board, which I shall show you in a minute. So pin number 5 should be the logic drive input. Pin number 6 should also be logic drive input. So pin number 5 and 6 should look exactly the same. Should be a nice sharp square wave on pins 5 and 6. Pin number 7, I think it's ground. Yeah, pin number 7. Oh no, pin number 7. Yeah, pin number 7 is ground. Pin number 8 is also, pin number 8 should be a drive wave that looks like this, nice and sharp again. A little bit of a curve on the way up and the way down, but it's about 7 volt RMS with 10 volts worth of input. And that's the same, that goes the same for both sides here. So both sides should have, I think, the same stuff going on. Yes, so both sides should have the same stuff going on. So what you need to do is you need to, obviously if you're repairing this amplifier, you need to remove all the FETs. I would remove the driver ICs. You will probably have killed this resistor, wait, what was it? Yeah, this resistor here, which is a 10 ohm resistor, and these 10 ohm resistors are responsible, they act like a fuse for the driver chip. So these will probably die if the driver dies. You'll probably also have perhaps lost this 4R7 resistor here and here. You also may have lost some 20 ohm resistors by the gates, so check all of the resistors to make around this area. There's not a great deal of them, just check all of them, make sure that they all read within tolerance, you know, they should be the correct values. Now, remove the MOSFETs, remove the driver IC chips, okay? And you want to make sure that with the driver IC chips removed that you have a good looking square wave on pins 5 and 6 of the ICs. If you do have a good looking square wave on pins 5 and 6, replace all the bad resistors, replace the 2 driver IC chips with HIP2101s, and replace the MOSFETs with IRFB 4410Z. If on pins 5 and 6 you don't have a good looking square wave, okay, then it's very possible that it damaged some of the drivers in the middle of the board that drive the final ICs. So if we move it along here and get this in view for you, just along from the output section, you can see here in the middle of the board there are some very, very small SOT23 transistor parts. You see those in there? Very, very tiny SOT23 transistor parts in here. So they are these ones here. Okay, we got 1, 2, 3, 4, and these are marked up as ZC and ZA. So they are PNP and NPN transistors, driver transistors, and these will drive the logic drive from the generation IC, which is somewhere under this lot, to the final drive ICs over here. So if you have bad looking logic drive waves by the 5 and 6 pins on the driver ICs, then you need to go back and check all of these. I would maybe replace all of these anyway, these ZC and ZA SOT23 transistors in the middle of the board. So if you have bad drive on the pins of the driver IC with it removed, remove all of these, remembering which ones go where. Okay, very important to remember which ones go where. Take a picture before you take them out, or note it down. Take all of them out, and with them out, probe the pads of these these transistors to make sure the square wave looks good on these pads. If the square wave looks good on these pads, then you should be able to replace the ZC and ZA with something equivalent or the same, and then you should, once you've replaced those with good ones, have the good square waves over here on pins 5 and 6 of the driver IC. If you still don't have good drive on these four, then you probably have killed the PWM generator, the Class D generation IC, which I think is, can't remember which one it is over here, because I think actually this amplifier wasn't damaged that badly. So, but yeah, you'd have to then look into what chip is generating the Class D switching waves that then get fed to the driver. So, but I think most of the time it's buffered enough. By the time it gets back to this part of the board, it's been buffered enough. You wouldn't likely damage the IC which is generating the Class D switch waves. So if you know, the last thing is that these will be damaged. So these ZC and ZA. So replace those. Replace the driver ICs, replace the resistors, replace the MOSFETs, and you should have a fully functional, up and running JL Audio 1000 watt amplifier that stays pretty cool and works a treat. So thank you very much for tuning in. This is just a very quick live stream just to go through that. Yeah, if you've got any questions on the JL Audio stuff, I have a good contact over here in the UK. We should be able to get some nice information if you're struggling with the repair of a JL Audio amplifier. So hit me up on facebook.com/bearvids. If you want to stay tuned in with these videos, then hit the subscribe button and hit the little bell next to the subscribe button, and that means you'll get notified whenever I am live on YouTube doing a stream like this. But yeah, until the next stream, guys, take it easy and have a good one.